All right, we're going to move on now to example number 3. And example number 3, we're going to be dealing with another type of word problem. And these are solving work problem. And they have to do with two people working together to accomplish some kind of goal. And we want to try to figure out how long it takes each of them or combined. It just depends on what the question asks here. So let's go through the problem and see if we can tackle this dude. And it failed. So it takes 2 carpet layers 4 hours to carpet a room. All right. If each worked alone, one of them can do the job in 1 hour less time than the other. How long will it take each carpet layer to complete the job? Okay, so that's the main question that we're trying to answer there is how long will it take each person? So we're actually going to find 2 answers then, right? How long is it going to take each person to complete the job? All right. So just like we did in the last example, we always want to label our variable, the unknown. And even though in our problem we need to derive 2 answers, we need to let x equal either the faster person or the slower person. And I'm going to go ahead and just start with the slower one. So I'm going to let x equal the slower. The slower dude. Oh, I want to go here. So the slower worker. Okay. All right, so what I did here was I created this chart, and we're actually are always going to use this chart when we're solving work problems. So it's kind of like a template, and once we fill out all these boxes, it helps the problem go a lot smoother. So let's see if we can fill it out given the information that we have up here, okay? All right, so the slower person. What is the person's rate per hour, okay? So the only information that we know is that it takes these guys 4 hours to do an entire room, and one person can do it 1 hour less. So we don't, how long does it take the slower guy to do it per hour? So in 1 hour, well, watch this here. I'm going to say in 1 hour, he can do it over x, 1 over x. Again, x stands for how much he can, or like the slower person. And I'm going to use 1 right here because it's in 1 hour time. So in 1 hour time, he can do it 1 over x. And it just depends on whatever x is, but we don't know for this case here, all right? So this would be the rate for the slower dude. Now for the faster guy, we're going to use the information that's given to us. It says one of them can do the job in 1 hour less. So that means you would have to take this time right here, if they can do it in x time, and then just subtract 1. Because like, for example, if they did it in 5, then they can do it in 5 minus 1, 4. If they can do it in 10, they can do it in 10 minus 1, 9. Okay, so basically I just took this answer and I subtracted 1 because it says in our problem that the faster person can do it in 1 hour less time. Okay, so time working together. How long or how fast can they do it together? Well, they can do it in 4 hours and 4 hours. So those are always going to be the same. It's how long they can do it together. So now this part right here, the way that you get this one is you multiply these guys right here. So what fractional part of the job do they actually get done? So you multiply 1 over x times 4. So that's 4 times 1 over x. But that's the same thing as just 4 over x, right? Because you do 4 times 1 is 4. You put a 1 underneath the 4. 1 times x is x. And same thing right here. I'm going to multiply 1 over x minus 1 times 4. So 4 times 1 over x minus 1. So multiply 4 and 1. So that's 4 over x minus 1. Okay? And I'll go ahead and highlight what we got right there. These are the 2 values. These are the fraction. That means this person gets 4 over x done, and this person gets 4 over x minus 1 done. Okay, and that's the fractional part of the job that's getting done per hour there. All right? Okay, so once this is all set up here, the way that this happens is this. The slower guy can do part of the job. The faster guy can do part of the job. So if you put these guys together, if you add the slower guy plus the faster guy, that's all going to equal 1 job, right? They can do 1 job together. So 4 Try that again. So 4 over x. Okay, so I'm taking this row right here, 4 over x, plus the 4 over x minus 1. That's all going to be equal to, how many jobs are they going to do? 1 job. Okay, this will always equal 1 because they did a fraction of a job, they did a fraction of a job, and when you add them together, they're going to do 1 job. Okay, so that's why the chart is important here. You take these two values, you take its sum, add them together, and it's going to be equal to 1 always. And now it looks like, just like the problems that we were doing in the beginning of this chapter, we have to go ahead and now solve for x. So our lowest common denominator is when you multiply all the denominators. So that's just x times x minus 1. All right, so let's go ahead and multiply everything by x times x minus 1, okay, because I multiplied those guys together. So over here, I'll have x times x minus 1, and we'll multiply that by 4 over x, and then plus x times x minus 1, and multiply that by 4 over x minus 1. And do x times x minus, if I could fit it in there, minus 1 times 1. But if I multiply by 1, it's just going to be itself right there. Okay. So now, let's see what happens here. Wata. That's so rad right there that those things cancel out. Super cool. So let's do the distributive property. 4 times x is 4x. 4 times negative 1, negative 4. Coming over here, the x minus 1s cancel out. So I just do 4 times x plus 4x equals, and do the distributive property right here. X times x is x squared. X times negative 1 is negative x. So now this just becomes now a quadratic problem that we need to solve. Let's go ahead and put it in standard form, meaning put all the terms on one side. So I can first combine those guys together and get negative 4 plus 8x equals x squared minus x. So let's add the 4 and let's subtract the 8x. So I'll just show both of those things in one step here. So I'm going to subtract 8x, but then I'm also going to add 4 to both sides. Okay, notice that you always do the opposite operation. So since it says minus 4, I'm going to add 4. It says plus 8, so I'm going to subtract 8. Wata. So those guys are gone. 0 equals x squared minus 9x plus 4. Okay. This guy will not be factorable. So once again, we need to revert to the quadro formula. You say, man, that formula seems to be pretty important. I mean, we use it a lot now. Yeah, it kind of gets long and all that, but it's kind of cool. I mean, look at how many things we can solve now with the quadratic formula. Pretty cool. So x equals negative b plus or minus the square roots of b squared minus 4ac all over 2a. All right, let's go ahead and plug in these values then. So my b value is negative 9. And I get negative 9. My a value is 1. My c value is quattro. My a value is uno. So x equals negative times a negative gives us our positive 9. Negative 9 squared is 81. Negative 4 times 1 times 4 is a negative 16. Right? And it's a negative times a positive. Just going to give us negative right there all over 2. So right now we're going to go ahead and do 9 plus or minus the square root of, let's see, 81 minus 16, going to give us a 65 all over 2. Okay, so since we're talking about a real life problem, you don't say, oh, one guy can do the job in 9 plus square root of 65 over 2 hours. Does that even make sense at all? I mean, we don't say things in real life in that kind of fashion. So we actually want to write out the decimal version of each of these. So we want to do the first one, 9 plus radical 65 over 2. And then x equals 9 minus square root of 65 all over 2. So we want to do the approximate decimal. And the reason why I'm going to use the approximate signs because we're going to round the decimal. And that's why the problem said to the nearest tenth there. So do the first one. So 9 plus radical 65, and I'm just using my calculator here, divide by 2. And this one I get 8.5. And in the context of the problem, we're talking about hours. Okay, so 8.5 hours. And this guy right here, 9 minus square root of 65. And I divide that by 2. And I get 0.5 hours. Okay. So let's make sense of this now. If you go back up to the top, X represent the slower worker. Okay. Now it's not possible to have the slower worker. Well, okay. Yeah, you could do it in one time, do it in 8.5 hours, and then one time do it in 0.5 hours, but that would be kind of weird. Like that means he's like super faster and then he's super slow. So actually one of these answers is not correct. In the context of the problem, if you go back up to the top here, remember the slower dude was, his rate is 1 over x, and the faster guy was 1 over x minus 1. I think that's what we put, right? X minus 1? Yeah. So watch what happens here. If we said that the slower guy does it in 0.5 hours in 30 minutes, okay, which really doesn't make sense, because if the problem says that they do it in 4 hours, I mean, how's this guy going to do it in 30 minutes, and yet that was supposed to be the slower guy? So that shouldn't make sense right now by saying 0.5. But if you plug this into right here, you're going to get 1 over negative 0.5, right? 0.5 minus 1 is negative 0.5. And somebody can't do something in negative time, right? So that right there should be an indication that that answer doesn't make sense. So we actually cross that answer out. That's not an answer. And the answer for the slower guy is 8.5 hours. Okay, so the slower dude is 8.5 hours. And the faster guy, the faster guy, let's see here. Oh, I'm sorry. It's 1 over 8.5. So we probably want to, show that right there. So let's do that over again there. Okay, so the slower guy does it. Okay, yeah. So the slower guy does it in 8.5 hours. So the slower guy does it in 8.5 hours. And the faster guy does it in 1 hour less. So that's going to be 7.5 hours. Again, this is by themselves, right? But then they could do it together. And then when they do it together, they do it for a total of 4 hours.